Good evening. My name is Jerry Mister, and I will be presenting my findings on Varda Space Industries, an in-space manufacturing company, or ISM. During this presentation, I will go over the following topic areas. Varda Space Industries is on the cutting edge of in-space manufacturing. They have already successfully demonstrated their unique capability to manufacture small molecule space drugs. The benefits of manufacturing in space is a purer form of chemicals and pharmaceuticals. Varda has grown their in-house ability to develop and manufacture the necessary components to build their ISM spacecraft. They are already targeting their next manufacturing products in fiber optics and gallium arsenide semiconductors. Similarly, these products benefit from being manufactured in space through the absence of imperfections associated with manufacturing these products on Earth. Varda is also working with the DoD on hypersonic reentry technology, which is not related to ISM, but worth noting. When I came across Varda, I immediately remembered a space mining paper I had done in a previous course. When putting that paper together, I came across a study, I believe it was from Harvard, that looked at the entire space mining value chain. The study concluded that the cost associated with developing, manufacturing, and launching the mining equipment, even if it was lighter relative to Earth mining equipment, along with remote operations and the logistics of returning tons of material back to Earth, made it unprofitable. If you reduce the weight of material to less than tons, then it would be unprofitable to even go after. And if it's unprofitable to bring back to Earth, then refining and manufacturing on Earth isn't possible. Therefore, when it comes to space mining and the associated ISM, resources mined in space will need to be used in space. So what is Varda doing that makes their ISM profitable? The most obvious reason is Varda isn't dealing in heavy mass. But there is also a huge market incentive in small molecule manufacturing. Small molecule market is worth billions and growing. The table captures a range of small molecule values ranging from very profitable to low profitability. The drugs being manufactured are among the most in demand for a wide range of uses, from cancer to ADHD. Simply put, any molecule is worth manufacturing in space if its cost per kilogram is more than the cost to launch. Varda has developed a free-flying spacecraft called Winnebago that consists of a manufacturing lab and re-entry vehicle. While the first three spacecraft were built by Rocket Lab, Varda has since integrated the manufacturing process in-house via 3D printing. The spacecraft has a total mass of approximately 300 kilograms and will manufacture in low Earth orbit for about 30 days. The spacecraft itself is expendable and only has a 3-month lifespan. Once the manufacturing is complete, the re-entry vehicle separates and returns to Earth. The spacecraft itself is deorbited into atmosphere. Varda, like many small space startup companies, benefit from the reduced cost to launch. The development of the Space Shuttle marked the first significant decline in launch costs per kilogram. Since the 1980s, more efficient propellants and engines have contributed to a steady decline. The next significant reduction in launch costs resulted in the success of the reusable launch vehicle by SpaceX. A Falcon 9 launching to low Earth orbit cost approximately $2,600 per kilogram. With the development of Starship, SpaceX estimates launch costs per kilogram could reduce to $50 per kilogram. And if we look at the weight associated with the W series spacecraft, you can see that their total launch to cost is $780,000. Varda's re-entry module is based on SpaceX's Dragon capsule. It uses old school Mercury program burn-in at Mach 25, and once re-entry module enters low Earth atmosphere, it uses a 2-stage parachute system to step down the descent speed. Just before landing, The reentry module fires solid propellant rockets to a soft landing speed of approximately 16 miles per hour. Logistically, the recovery operation only requires a small crew of 2 or 3 people and a recovery vehicle. While I could not obtain the exact cost of recovery, the small logistical footprint compared to a Dragon capsule recovery at sea strongly suggests a much lower cost. So perhaps looking at space mining was a bad comparison given the scale. However, it did force me to look into how Varda, a leader in ISM, is doing business. Without the obvious costs associated with space mining, Varda is dealing in low mass ISM, where the cost to launch per kilogram is not a prohibitive cost. They have leveraged new technologies and brought manufacturing of their Winnebago spacecraft in-house. And lastly, they have targeted a highly profitable market in the small molecule manufacturing market. All of this combines into a very profitable space manufacturing value chain. Looking at the table, we can see Varda's initial total mission cost of 12 million would have yielded a profit over 22 million for the small molecule drug Revlimid. And as the chart shows, as Varda's total mission cost reduces, their profit for the same drug will increase. This concludes my presentation. Are there any questions?